Hello, world. Thanks for joining Pivot Conference and welcome to this session. I'm Dani Merino. I'm the R&D lead inside of Project InnerSpace, and today I'm going to be hosting our AI competition that is focused on LLM models, large language models. Yeah. And if you ask yourself on why we're doing this, you probably saw also our datathon organized in collaboration with SPE, in which we were looking at the value of AI in order to sort out data and numbers and real-time optimizations and all that. But today we're talking about text as I would say, a bleeding edge and new applications of AI and what we call generative AI and natural language processing. Yeah. And you probably know about these concepts because of ChatGPT and their conversational chatbots. But as you will see when you see the pictures from our finalists, this goes beyond just conversations. Yeah. And the reason why we wanted to organize this contest is that we didn't want geothermal to stay behind what's happening around the world, and large language models are becoming the bleeding edge for many industries, and we just didn't want geothermal to fall behind. And also, we consider this an opportunity to engage with our, let's say, youngest generations and young professionals that are probably more keen into these new capabilities, and we just wanted to benefit from that. How we organized this contest, we again collaborated with SPE and the technical section of data science and engineering analytics. Yeah, we organized a virtual competition throughout the summer just to showcase the potential of AI-assisted workflows covering the full life cycle of geothermal. We opened it to everybody, to all potential AI enthusiasts, all those people that have been following the advances in LLM over the last year. And again, we thought it was a great opportunity for young professionals and students to join and start exploring what they could be doing for geothermal. Yeah. So the proposal was very basic. We didn't really have any sort of data sets ready for them to work on. We just opened up for them to develop and deliver any sort of workflow that would work for any discipline, from geophysics, geology, drilling, completions, production, HSE, basically anything, because all we wanted to highlight is the potential of LLM models applied to geothermal. Yeah. So as I said, over the summer, we allow our teams to get together, to start working and deliver the results. We had a group of technical experts, 1 internal and 4 external to Project InnerSpace, that had a look at the work of the different groups and selected the 4 finalists that today are going to be presenting their work via pictures, via video that we're going to be showing shortly. And later on, we will have the awards ceremony, yeah, where we will show the results of the technical committee, awarding the prizes for the first, second, and third prizes. Yes, but also we also want to hear you as an audience and hear what you consider was the application, the workflow that really got you intrigued and you wanted to hear a bit more, or you consider the one that would have the greatest impact for geothermal. Yes. So now we're going to be watching the video with our 4 finalists and the pitches that they made proposing LLM-based workflows and how they can be applied to geothermal. Please.
Hello, everyone. This is my recording for the Geothermal AI Innovation competitions to combine LLM workflows and geothermal applications. My name is Jorge Medina, and I'm a second-year PhD student at the University of Rochester. And since this year, I'm also an LLM aficionado. So the problem I decided to tackle is that Rochester is one of the coldest and snowiest cities in the US. Utility bills skyrocket during the winter because of this. And because of its location, very high up the north, popular renewable energy systems like solar are not very applicable. This brought me to geothermal HVAC systems as an interesting alternative. But when I was trying to look into it, it's not straightforward to get technical information. And there's a lack of open source software to help in design these systems. So here comes my solution. My proposal is GeoBot, an LLM-powered chatbot agent that has different capabilities to answer your questions, design pipelines, and even give graphical outputs so you can see what you're trying to design. The workflow is very straightforward. It uses a Miracle implementation. This is nothing else than an agent that has different tools, and it accesses them iteratively to answer your question. After every tool is called, you get an observation. The agent decides if it can answer the question. If not, it just keeps looping through it until it finally gets enough information to answer your question. Couple examples, Q&A. I can ask what are the benefits of installing different systems of HVAC system, different types of HVAC systems. And you can see how it says, oh, I don't know enough information. Let me look into it. And it actually gathers information so it can ground its answer and doesn't hallucinate. So here you can see how it gives some comparisons between vertical and horizontal systems. Another more technical use example is I live in Rochester, New York. I already know my heat load requirements for my house. Please help me design a system. So immediately the bot decides that it doesn't have enough information to do it. So the first thing it gathers is the ground temperature. So it goes and it says, okay, Rochester, New York, and it gets a range of temperatures, so it helps towards the design of the pipeline. Interestingly enough, you can also see that because Rochester is very cold, it notices that the working temperature can actually be as low as under freezing point. So you need an antifreeze. So that will be included in consideration for the system design, because antifreeze will change the properties of the fluid. In this case, it could be water. But what happens if I even have even less information? That's the beauty about LLMs, how flexible they are. Like if I only say I just have the heat load, they will be like, hey, but I don't even know where do you live. So at least it needs that in order to like get an approximate value of what's the ground temperature at your house. Then after it asks for it, it prompts for it, you can answer back, and then it can just continue as the example before. And as I was saying earlier, it can even give graphical outputs. Like, can you please do a diagram of a vertical loop system with two pipes? And like, it can do that too. Thanks a lot. This software is open source. You can find it on my GitHub. If you have any questions, please contact me, and I was very happy to participate.
Hello everyone, my name is Pejman, and together with my friend Sadef, we've participated in this hackathon about the application of large language models in the geothermal sector. And today I would like to give you a story about this guy, Bart, together with his friend Lama, and how they put their effort together to create a technology which is not called ChatGPT, it's actually called ChatGeoPT, to help the geothermal sector. So Bart is operating this geothermal field in the background, and he's a strong believer in the role of geothermal for providing our power and heating demand currently and in the future. However, if you look into the asset that he's operating, there are several issues sometimes, like corrosion, like clogging and scaling, which has a big impact on the safety of the asset, on the performance, and also on the cost associated with running this plant. So like many other people, Bart went to ChatGPT and asked for help. How can I mitigate these corrosion issues in my system? Can you give me 5 publications on corrosion issues in geothermal systems? Maybe I can learn from it. And of course, ChatGPT provides an answer. But the problem is sometimes these answers are not verified and correct. And asking for the publication, there are a list of publications here that's the topic, the paper, and also the authors, they do not exist. So this is the part that the large language model hallucinates, and Bart was not happy about it. He was concerned, and he went to Llama and said, I'm afraid and worried that if it goes like this, people will stop using this brilliant technology of large language models. So how can we work together to bring that domain-specific semantics and also the most updated knowledge of our domain into the large language models? Having a more transparent data set, and sometimes even use the information and data that we have to give that to the large language model so that they can give us a better answer. But most importantly, if I ask the large language model, where did you get this information from? They can give us a reference. So they put their effort together, And they created this chat GPT that now if you ask the questions like, give me 5 publications about corrosion in geothermal systems, it will provide you the 5 publications that actually exist and the authors that exist. So this is a very, very important part of the chat GPT. Let's go inside the technology and see how it works. So in order to bring that knowledge and semantics and the language of the domain to the large language model, initially a database is required, a database which contains the information from that sector. And in this case, an API was made to retrieve information from multiple data repositories from the publications and also more than 300 PDFs, which has been collected in the past years on the geothermal operation and different challenges in the production of geothermal. And they have all been put together, which is more than 220,000 data points. And this information is also through an API was translated into the language of interest, depending on in which region people wants to use this tool. So this geodatabase is a domain and language specific database. And this, in conjunction with the large language model, it can do a lot. So first, BART can ask keywords to the model, like a scaling, and using a zero-shot classification on this rich database, the evolution of the scaling topic over the years and for the different assets can actually be provided, and that can give a lot of insights. So the trends of the information and the keywords can be provided to the user. The second part is just asking a question. So ask Llama a question about how can I mitigate corrosion in the system. Since this is now looking into this big geodatabase, it provides answers which is according to the information in the geodatabase, plus it will provide the references that do exist in this database. And eventually bringing all of this together, these models can be fine-tuned to give you the verified and domain-specific response. And it goes beyond that because BART and Llama wanted people to use this. So an app was made around this that can look into this geodatabase and in this case, providing the keywords to see how certain topics have been evolving in the geothermal sector, like scaling, corrosion, and in this case, energy storage. They are not the only one who think this is a great technology, because in a survey that was sent online and 18 people has participated in this, more than 60% were in favor of answers provided by ChatGPT compared to the GPT 3.5. A lot still can be done. This hackathon is not the end of it, but ChatGPT, which is an effort of BART and Llama together, is seen as an AI assistant to the geoenergy sector, and there will be more and more to be done in this field.
Okay, so my name is Tyler Hargrove, and this is my talk. It's on leveraging large language models and databases for real-time well site and field communications. So we're using the cutting-edge power of AI and multimodal databases to augment older, slower services like email. So our vision is to create cloud-based multimodal databases. You can use all kinds of tools for that. Any user can upload files. Our mission is to replace the old email system or augment it in such a way where we can have real-time communication from the field to and from the office. And using large language models, we can use question and answer and other tools like that where each user can ask our data questions without actually having to call up or email or schedule meetings for particular people if it can be answered that way. So there will be 2 types of terminals. There's a global access terminal, a regulated terminal. Our goal is to achieve like a seamless environment which enables service companies and operators the ability to access all of the real-time drilling data. This is a game changer for all kinds of drilling, especially geothermal, because we've got pressure and temperature. We're dealing with regimes that really require this up to the minute monitoring. So here's our old email system. You know, your user over here, he generates stuff. It goes out to all these people. It takes time here. It takes time here. And then the worst part of it is everybody's got questions and they all want to ask this guy everything. So he gets a million emails in return. So it just really bogs down our user process. So here I'm going to generate whatever kind of media, stuff that can't even go in email because it's so large, like time series or video. Our little bot will file it. Our other little bots will send it to the right place and update things in real time. Meanwhile, feedback can come back through another bot that can talk to our user. So it's almost like a constant meeting. So here's sort of an image one. This is a real visualization from Google and Nomic AI, which shows a bunch of images and text in a categorized segmented cloud. And that's sort of what this will look like for each well or for each category. And then here's our theoretical framework. We've got our service providers, our drilling computer, and then even after drilling, we can have wireline completions, etc. All go through these databases and web front end that goes to management. In the meanwhile, we can utilize AI for all kinds of time series, pressure temperature analyses, and really make real-time decisions on where to set casing, when to pull the bit, things like that. And do we need to keep drilling? Do we what's our costs so far? That takes a human quite a lot of time to add up all the invoices and stuff like that. Well, why not automate it? I mean, we can really do that and augment our, you should still probably have people check all of this and do it all by hand. But in the meantime, you can have it quickly do these type of things. So management can make really informed, rapid, real-time decisions from the office, from home, from their cell phone, and look at what's going on the rig, look at what's going on the frac crew, or whatever it happens to be, and really make rapid decisions and coordinate. So this will save hundreds of thousands of dollars in problems that occur because you'll have more eyes on your drilling. Okay, this is a little bot I made that's a question and answer bot off of PDFs. I've just loaded one, but you can load multiple PDFs into this. Basically, you don't have to be a domain expert. A manager could ask this, an owner could ask all kinds of questions to our databases of field data, textbooks, all kinds of stuff, and get answers on the spot without actually interrupting the workflow of our domain expert, so that everyone can prepare for meetings. We can sort of make more informed decisions rapidly without this bottleneck of communication and setting up meetings, setting up times to talk about things. So this really helps you overcome those challenges. Just want to say thank you for coming to this talk.
Hello, everyone. My name is G. I'm so glad to attend this geothermal AI innovation competition. Today, my topic is improving geothermal drilling efficiency with predictive LLM. As we all know that geothermal is a renewable, zero-carbon, stable 24/7 energy resource with an even smaller footprint than other renewables like solar and wind. Geothermal well is about to rocketing to meet energy needs, though it's currently much smaller than the wells drilled for oil and gas. There are a few challenges associated with the geothermal drilling. First, drilling into geothermal formation is usually challenging and very costly. Several studies have established that the drilling can make up to more than 50% of overall project cost. So it's really demanding to reduce the geothermal drilling cost. And drilling predictive analysis is one of the key challenges in improving drilling. Our rate of penetration, which is ROP or drill speed, and reduce potential hazards during the drilling process. So our solution here is over the last month, we tried to propose a workflow to apply LLM-based workflow for drilling predictive analysis. It's generally using integrated data source from both oil and gas and geothermal. Unfortunately, we don't find much from geothermal open source data, but from oil and gas, and also we try to construct a LLM-based predictive model pre-trained with oil and gas drilling process. And we try to construct a continuous learning structure so that we can fine-tune for geothermal wells and apply it to geothermal drilling to optimize the drilling speed, RP. For those who may not quite understand the drilling process, I here have two figures to illustrate. Is first, if we have a few wells has been drilled, we can use the data gathered to construct the model to predict or to apply in real time for the undrilled well. In the drilling process, we can also use the data from the section we have already been drilled and apply them to the section we are going to drill next. So that's the main idea. We tried LLM-based type of RP predict model. We call it the self-attention model, modified from transformer. We also compare this attention model with other sequential models like STM and GRU. By the way, structure is showing on the left top. And we test on 4 oil and gas wells from an open source data set. Unfortunately, we don't find proper open source geothermal drilling data. So we used oil and gas and make it clear so that we can further develop for geothermal drilling process. So we then perform some performance verification and sensitivity analysis. Here are a few examples as we have 4 wells. We're going from the drilling history that we use the first well to predict for the second one, and then the first and the second for the third one, and so on. So here we assembled some results from 3 methods and also shows how accurately predicted the model is, especially on the right is the self-attention model, which shows a good match for the first case, and then we goes on with well A and B for well C. Yeah, also good results for attention model, and also A, B, C for well D. So lumping up those results all together, we can see that in this 3 figure for GRU, STM, and the last on the bottom one is the self-attention model. We see that along we drill more wells and we gathered more data, and the model in general, all of them have increased accuracy and predictive length ahead of bid, which means how further we can predict ahead of our current situation. Most importantly, on the bottom figure shows that the LLM-based RP predict model is very stable and in the predictive capability. The overall range here is less than 3%, especially when we goes to the third case. The line goes from the blue, orange, and then green, which means the green one is the last one. So the significance here is that we try to propose an example of LLM type of drilling predictive analysis model for ROP here, which is demonstrated superior in terms of accuracy and prediction length ahead of the bid. And also we try to propose a continuous learning structure so that it can be a feasible workflow to leverage oil and gas drilling data, knowledge, and experience, which are far more than what we have for geothermal drilling. But the LLM-based model can have a pre-trained process and then fine-tuned for a specific case like geothermal drilling. That's the main idea behind the workflow. And also, this could be very potential to apply in geothermal drilling, which can increase RP by as far as 20 to 50%. A future work, of course, is test on more geothermal drilling data, and we of course like to collaborate jointly to reduce the geothermal drilling cost, such that we have better geothermal projects to be more efficient. Thanks very much. That's all for my presentation. If you have any questions, reach me at this address. Thank you again.
that's what happens when you're broadcasting live. Yeah. So hello again. We're back. I just wanted to send first a reminder that all of the presentations that you have seen today will be available shortly in our YouTube channel. Yes. And before we move further, I wanted to open now, while you have all these videos fresh, I wanted to open the voting poll because we want to hear from you. We want to hear your voice and want to understand which one of these 4 researchers has inspired you the most. Yeah. Who has convinced you that the workflow that they have created or ideated will create the biggest impact into geothermal. So you will soon see a pop-up window coming out in your screen, yeah? And you're gonna have a few minutes to vote, yeah? And while that's happening, while you're starting to vote, while you start to see that pop-up window, I wanted to introduce Pushpesh, yeah? Pushpesh Sharma. He's been paramount, he's very instrumental for the success of this contest. He's the senior product manager at Aspentech, but he's also the program chair for SPE Technical Session on Data Science and Engineering Analytics. Hello, Pushpesh. How are you?
Thank you, Dani. Thank you so much for inviting me, and thank you so much for having me. I think it's a pleasure being part of this and the Datathon that we had before. So I'm actually very excited to talk about it. Thank you so much.
Excellent. See, I mean, you did mention the Datathon. You've organized plenty of those, and I just wanted to know what was different in this one. Yeah, it was not really a Datathon. So what surprised you the most out of it?
Oh, I think this is a completely unique concept, right? Because Datathon and Hackathon have been it's been done multiple times, and the format is a little clear, and you have a data set, you're solving a problem. But this was because it's the cutting edge of technology, ChatGPT, large language models. That's all the rage right now. Everybody is excited about them. We see a lot of potential. So I think it was very, very different because this is our first time interacting with this technology too. So I really liked it because of the possibilities that you can explore with these workflows. So it's completely different, but I think it has more potential, and I'm looking forward to do more of these in the future.
Fantastic. And you mentioned how different this was. There was one element in particular that for me was a very meaningful situation is when we organized the AI competition. Our kickoff had a couple of keynotes. Yeah, we had Pratik Kumar from India, ONGC, and also Mike Caldas from University of Rochester giving us keynotes. Yeah, they were giving us presentation to the participants on how to do things, what to do, how to benefit from LLM. And the combined age of these keynote speakers was less than mine. I have no problem in admitting it. How did you feel in those keynotes, and how different they were compared to the standard conference that the keynotes are typically my age?
Yeah, no, I think that's a key difference that you pointed out here, because ChatGPT and this is going to be the tool of the future. So I think the younger generation is gonna embrace it faster than anybody else. So it's very, how would I say, it's like very very nice to see that they were the one taking the lead, and we can always learn from the younger generation, especially for ChatGPT. I know like I have so much to learn, and for I guess the next generation, it's gonna be very obvious and very natural. So it's very fitting that we got the keynotes, and I think that's something we wanted to do, right? Oil and gas has been a little bit conventional industry, and when you bring in this young blood, that's another way to attract talent and retain talent in the industry. So I think that's a very good kind of silver lining from this.
A big shout out for Mike and Pratik from here. You were extraordinary in your keynotes. Yeah, in the end, and we saw 4 videos that were quite different from each other, that they were attacking very different problems. This highlights a lot the opportunities that these kind of workflows can bring to accelerate. Do you think there's anything that LLM cannot do? I mean, there's so many ideas out there that we didn't really explore in this one that certainly we will in the next one, right?
Oh yeah, I think that was another uniqueness about this, because it was open-ended, so which kind of opens a lot of doors. Like in the introduction you mentioned, you can talk about geology, you can talk about drilling, completion. So we left it open-ended. The way anybody is, whatever your expertise is, you can actually create a solution based on that, and LLM kind of enables that, because you don't have to have the complete picture, because LLM can fit the gap. So I think that's the potential of this technology, that even if you start from a point of technology where you don't know all the things, you can try to make sense of the complete picture based on this digital technology, which is trained on a vast variety of data. And some of our participants showed us also that how do you utilize this and how it will make a difference. But open-endedness, I think was the key, because that's how we got all these very different overviews of these workflows.
Yeah, and I do hope this helped to show also the world, our geothermal ecosystem, that ChatGPT, great, but it's just conversation is just one of the many things that you can do, and you can combine LLM with other things, no, and have some tools linked to the LLM models and to the chatbot, so that they become an operator that can be way more powerful than just quick questions and answering, from these kind of systems. Yeah.
Oh no, yeah, I think ChatGPT alone is not enough, because I feel like ChatGPT is a tool to kind of systemize your thought, but then you still have to prompt it, you still have to provide some inputs, and it will give you a very good way to systemize your thought, but you still need a little bit of guidance. And as our participant also showed, fine-tuning with some databases, putting some structure around this LLM workflow will actually even enhance it even more. Yeah.
Fantastic. Yeah. And we will move on now into the awarding our awards. Yeah. Let me just mention first that we follow a criteria in order to select who has won. We had, as I mentioned before, 5 judges with using several criteria to identify what was the best option for us to award the prize today. We consider the impact in that particular case study. We consider the originality of the proposal, also the scalability or adaptability to other processes, and finally, the clarity of the presentation. I cannot stress this enough. It's not enough to have a great idea. You also have to be able to sell it. And considering all this, we're going to get started with the awards. Yes. I'm going to announce first the People's Choice, which goes to Peshman Omrani from TNO. He got 53% of the votes from our audience, which is great. Congratulations, Peshman. And we start now with the announcements of the, let's call it the technical awards. Please go ahead, Pushpesh, with the third prize.
Yeah, from the input from the technical committee, the third prize goes to Jorge Medina from University of Rochester. Congratulations, Jorge.
Excellent. Jorge presented the GeoBot and LLM-powered chatbox agent. Our second prize travels to Europe, to Norway, with GCAO from eDrilling, with his improving drilling efficiency with predictive LLM.
And the first prize goes to, and I'm very happy to see that audience also agreed with the technical committee. So the first prize goes to Peshman Omrani from TNO Energy. Congratulations.
Congratulations. And I'm being told that he's jumping around the channels in Delft. Please don't jump into the water. It's too cold already. Congratulations, Peshman. And it was a very tight competition. Congratulations to everybody. And Tyler, our runner-up, thanks for participating. I really like the way that you called emails non-productive time for drilling. And please keep pushing. Your ideas are great as well. All right, Pushpesh, thanks a lot for the very nice conversation. I'm sure that we will organize more events, more contests, more datathons, more AI innovations, many more ideas in our quest to highlight the opportunities that are coming up for geothermal to accelerate their growth.
No, thank you so much, Dani, and I'm very excited about what we are going to do in future. So thank you.
All right, audience, we're reaching the end of the day. It's been great. We've traveled to Nigeria. We've also assessed different new technologies in drilling, how to make the best possible wells. We looked into AI. We looked into advanced market commitments. We looked into many, many different things. And the best part of it all is that it's not today. It's not the last day. It's not even the last week. We'll continue in our Pivot conference next week, starting in Reno with our friends in Geothermal Rising and ending up in our grand finale in Houston. So please don't miss it. Stay tuned for the agenda. We'll be releasing shortly. Yes. And remember that this Pivot conference throughout the month of September is trying to make September the geothermal month, and all these efforts with PIVOT are trying to make the 20s the geothermal decade. Yeah. Thank you very much for listening. You've been a great audience. Thank you again, and good night.